So welcome to this session. So now we go to see the topic linear differential equation with a constant coefficient. So the general form of nth order linear differential equation with the constant coefficient is a naught into nth derivative of y with respect to n plus a1 into n minus 1th derivative of y with respect to x plus a2 into n minus 2th derivative of y with respect to x plus up to etc. an into y. So that is equal to r of x. So here in your left hand side is a ordinary uh, that is a linear differential equations with n order. Right hand side is maybe the r of x. R of x may be trigonometric or algebraic or maybe it is a constant. So it maybe depends upon the cases. So where a0, a1, a2, an are constant with a0 must be always non-zero. If r of x is equal to 0, then the equation 1 becomes like this. So r of x tends to 0. Then the equation is called homogeneous equation. So the general solution of 1 is y is equal to complementary function plus particular integral. So the solution of this equation 1, so we need to find two things. One is a complementary function and then particular integral. So the sum of complementary function plus particular integral, so is the solution of the given general solution. So that is y is equal to simply we call as CF plus PI. So the general solution of ordinary linear differential equation is also known as complete solution. So here we go to see some notations. So when here the whole unit we have taken capital D means d by dx, d square means d square by dx square. So d cube means d cube by dx cube. So d power 4 means d power 4 divided by dx power 4. So fourth derivative. So therefore equation 1 can be written as, so we can write like this. So d power n divided d power n y by d x power n we can write as d capital D power n and so on, take it as equation number 3. So commonly bring out the y outside in your left hand side, we will get this equation number 4. So procedure to find complementary functions. Replace r of x is equal to 0. So we get the homogeneous equation. So like this. So equation 4 we can replace r of x is equal to 0, we will get equation number 5. So step 1, replace d is equal to m. So once we replace we will get this. So this equation number 6 is called auxiliary equation. Solve, we will get a roots. So let the roots may be m1, m2, m3 up to etc. mn. So let us consider the two roots m1 and m2 are real root and unequal. Then the complementary function is CF is equal to A e power m1x plus B e power m2x. So in the case 1b, let us consider the roots m1, m2, m3. Three roots are real and unequal. Then the complementary function is CF is equal to A e power m1x plus B e power m2x plus C e power m3x. Similarly, we can extend up to how many roots are there, so that A into exponential of that term. Similarly, we can extend up to n roots. So next case 2. Let us consider the two roots m1 and m2 are real and equal. So in the previous case, we have discussed real and unequal. Now we discuss real and equal. So then the complementary function is CF is equal to A plus BX into e power mx. So next, let us consider the three roots. Three roots are real and equal. m1, m2, m3 all should be equal to m. The m is a real number, any real number. Then the complementary function CF is equal to a plus bx plus cx square into e power mx. Similarly, we can extend up to n roots. So let us consider the three root m1, m2, m3. So here all the roots are real. Two roots are to 2 are equal and the third one is unequal. Let us consider M1, M2, M3 are 3 roots. M1 and M2 is similar, equal, and M3 is not equal. So then the complementary function is, so since two roots are equal and M1, M2 which is equal to M, so we can write A plus Bx into e power Mx plus C into e power M3x. So let us consider the four roots M1, M2, M3, M4. Here all the roots are real and two roots are equal and another two roots are unequal. So therefore M1, M2 is equal to M. So M3, M4s are not equal. Therefore A plus Bx into e power Mx. Then we can use the case 1. C into e power M3x, D into e power M4x. Similarly, we can extend up to n roots. So next case 2. In the D part, let us consider the four roots M1, M2, M3, M4. So two roots are equal and another two roots are equal. So M1, M2 is equal to MA, M3, M4 is equal to MB. So MA, MB is not equal to actually. MA and MB are not equal. Then the complementary function is A plus Bx into e power MAX plus C plus Dx into e power MBX. Similarly, we can extend up to n roots. Next case 3. If the roots are up to previous case, we have to discuss the real roots. Now the roots are complex. Say alpha plus or minus beta. So M1 is nothing but alpha plus I beta. M2 is nothing but alpha minus I beta. So therefore the complementary function is e power alpha x, a cos beta x plus b sin beta x. Here we can replace alpha and beta value. So we'll get a complementary function. Suppose we can consider the two complex roots alpha 1 plus or minus I beta 1 and alpha 2 plus or minus I beta 2. So then the complementary function is e power alpha 1 alpha 1 x into a cos beta x plus b sin beta x plus e power alpha 2 into c cos beta 2x and d sin beta 2x. Here we can replace alpha 1 beta 1 and alpha 2 beta 2. Similarly, we can extend up to n roots. Now type 1. So r of x is equal to 0. So therefore our right hand side is 0. So that is we can take as type 1. Solve the differential equation d square y by dx square minus 4 into dy by dx plus 3y equal to 0. So given d square y by dx square minus 4 dy by dx plus 3y equal to 0. So use the notation. So d square by dx square we have to use a capital D square. D by dx we can use the capital D. So we get replace the notations. We will get capital D square into y minus 4 dy plus 3y. Commonly bring out the y outside. We will get d square minus 4d plus 3 into y. So now replace d equal to m. Wherever capital D is there, we can replace m. We will get auxiliary equation. Once we replace d is equal to m, we will get m square minus 4m plus 3 equal to 0. Since it is a quadratic equation, so we can find a root, two roots are there. So therefore minus 4m I can split into minus 3m minus m. Commonly bring out the m outside in the first two terms. So we will get in the first term m square is there. I commonly bring out the 1m only outside, you will get remaining term is m. In the second term minus 3m is there. So in that minus 3m I can bring out only m. We will get minus 3. Remaining terms are minus 3. Therefore similarly, I can bring negative outside from the fourth and fifth term. So we'll get minus of m minus 3. So the first term m minus 3, another m minus 3, commonly bring out the m minus 3 outside, we will get m minus 1. So therefore the roots are m1 is equal to 3 and m2 is equal to 1. So therefore complementary function here, the roots are real and unequal, case 1. So the complementary function is a e power m1x plus b e power m2x. Here m1 and m2 are 3 and 1. So therefore here whenever only right hand side is 0, so particular integral is 0. So at the time we can consider only complementary function is a solution of the given differential equations. So y is equal to a e power 3x plus b power x. So which is the solution of the given problem. So now we will move to the next problem. Solve d square minus 2d plus 2 into y is equal to 0. So this is the given. So replace d is equal to m. We will get auxiliary equation. Here a is equal to 1, b is equal to minus 2, c is equal to 2. We can use the quadratic formulas also. So m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So we can replace the value, simplify it, we will get the roots are 1 plus or minus I. Therefore, alpha is equal to 1, beta is also 1. So therefore, the complementary function is, general formula is complete, CF is equal to e power alpha x, a cos beta x plus b sin beta x. Replace alpha and beta, we will get a complementary function. Since RH is 0, only complementary function is the solution. Particular integral is 0. Therefore, y is equal to, so e power x, a cos x plus b sin x. So next, solve 4d square minus 4d plus 1 into y is equal to 0. So therefore, so we can, as usual, the same methodology. So the auxiliary equation, replace d is equal to m, we will get this. So from this we can split that term, minus 4 2m minus 2m. From this we can calculate, we'll get m1 is equal to 1 by 2, m2 is equal to 1 by 2. So the complementary function is, since both the roots are real and equal, so therefore CF is equal to a plus bx into e power mx. So CF is equal to a plus bx into e power 1 by 2x, m is 1 by 2. Therefore y is equal to a plus bx into e power x by 2. So next, type 2. So the previous case, type 1, we took r of x is equal to 0. Now we took r of x is a non-zero function. So that is equal to e to the power a x. So procedure to find the particular integral. So particular integral is equal to 1 by f of d into e power ax. So f of d is a given term. So we can replace e power ax. So replace d is equal to a. So particular integral is equal to, wherever in the f of d, capital D is equal to a, we will get this. Suppose this is the particular integral if f of a should be non-zero. Suppose f of a is 0 means, then multiple x in the numerator and differentiating the denominator with respect to t, only denominator only. So we get particular integral is equal to x divided by f dash of d into e power ax. So replace d is equal to a, we will get x divided by f dash of a into e power ax. Suppose if it is f of a, f dash of a is 0. Suppose if it is equal to 0, we can do the above process again. So now we will go to solve the problem. So problem number 1. So solve d square plus 6d plus 5 into y is equal to, so e to the power 2x. So solution, given d square plus 6d plus 5 into y is equal to e power 2x. So the auxiliary equation is m square plus 6m plus 5 equal to 0. Replace m is d is equal to m and r of x should be 0. So therefore, from this we can find the two roots. The roots are m1 is equal to minus 5 and m2 is equal to minus 1. So the complementary function is a e power m1x plus b e power m2x. m1 is minus 5, m2 is minus 1. So we can replace. So now we need to find the particular integral. So pi is equal to 1 by f of d into e power ax. Our f of d is equal to d square plus 6d plus 5 into e to the power 2x. So here d is, we want to replace d is equal to a. A is nothing but coefficient of x in the exponential term. Here the coefficient of x is 2. So therefore a is equal to 2. So we want to replace d, instead of wherever d is there, we can replace 2. So we can solve it, we will get, so 1 by 21 into e to the power ax. Since the f of a is non-zero, so which is the particular integral, therefore the general solution is complementary function plus particular integral, that is equal to cf plus pi. So already we know the two we found the solution value of the two terms, complementary function plus particular integral. So the complementary function is a e to the power minus 5x plus b e to the power minus x, and the particular integral is 1 by 21 and t e power 2x. We replaced it, we will get the solution. So next problem. So solve d square plus 4d plus 5 into y is equal to 2 cos hx. So given d square plus 4d plus 5 into y is equal to 2 cos hx, already we know the formula. So cos hx we can write in term of exponential term. So 2 into e power x plus e power minus 2x divided by 2. So 2 and 2 get cancelled, we can get e power x plus e power minus x. So the auxiliary equation, we can replace d in terms of m. So we'll get a is equal to 1, b is equal to 4, c is equal to 5 since it is a quadratic equation. So by using the formula, we will get a roots. So therefore roots are minus 2 plus or minus I. Here alpha is equal to minus 2, beta is equal to 1. So the complementary function is Cf is equal to e power alpha x, a cos beta x plus b sin beta x. So replace alpha and beta, we will get complementary function is equal to e power minus 2x, a cos x plus b sin x. Now to find the particular integral. So particular integral is equal to 1 by f of d into r of x. So replace f of d and r of x, we will get this. So I can multiple the 1 by f of d in the e power x plus 1 by f of d into e power minus x. So here we can replace d in terms of a. So this is to be taken as particular integral 1 and particular integral 2. Consider the particular integral 1. So here we replace d in terms of a. A is nothing but 1. So wherever d is there, we can replace 1. So we will get 1 by 10 into e to the power x. Therefore, since the denominator is non-zero, therefore, next we need to find the particular integral 2. So replace d in terms of a in terms of minus 1. Therefore, d is equal to minus 1. So we'll get this. Simplify this, we will get particular integral 2 is equal to 1 by 2 into e to the power minus x. So now we combined both P1 and P2. So we will get this. So therefore general solution is complementary function plus particular integral. So the complementary function and particular integral we replaced here, we will get a solution. So next type 3. So here r of x is a trigonometric functions. Either it is a sin ax or cos ax. So procedure to find the particular integral. So particular integral is equal to 1 by f of d square into r of x. R of x is either sin ax or cos ax. So replace d square in terms of minus a square. So we will get particular integral is equal to 1 by f of minus a square into e power minus ax. So after that, if f of denominator is non-zero, you stop the process. Otherwise, if denominator is 0, we can multiple x in the numerator and differentiating the denominator alone with respect to d. So we will get x into particular integral is equal to x divided by f dash of d square into e to the power ax. So again replace d in terms of minus a square, we'll get this. Suppose if it is 0, so we can do the above process again. So problem number 1. Solve d square minus 4d plus 3 into y is equal to sin 3x into cos 2x. So we know the formula sin a cos b. So that is nothing but sin a plus b plus sin a minus b divided by 2. So therefore we can use the formula here. A is equal to 3, b is equal to 2. So we'll get 1 by 2 into sin 5x plus sin x split into two terms. So now we need to find the complementary function. So solve d square minus 4d plus 3 into y is equal to 0. So the auxiliary equation is replace d in terms of m. So since the quadratic equation, we solve this, will get the roots are 1 and 3. So replace the roots 1 and 3, will get complementary function is equal to a e power x plus b e power 3x. So now to find the particular integral, so 1 by f of d into r of x. So f of d is nothing but d square minus 4d plus 3. R of x is 1 by 2 into sin 5x plus 1 by 2 into sin x. So the particular integral is equal to 1 by 2 into 1 divided by d square minus 4d plus 3 into sin 5x. So 1 by 2 into 1 divided by d square minus 4d plus 3 into sin x. So therefore, let us consider the first term we taken as particular integral 1, the second term we taken as particular integral 2. So now we go to find the particular integral 1. So consider the value. So now replace d square in terms of minus a square. Here a is nothing but 5. So minus 25. Wherever d square is there, we can replace only wherever d square only we can able to replace, not in d. So therefore, instead of d square, we can replace minus a square. Here minus a square is nothing but minus 25. So therefore, wherever d square is there, we can replace minus 25 and simplify it, we'll get this case. So now we can uh, find, we can replace only in terms of d. Therefore, we can multiple the take the conjugate. So 2d minus 11 divided by 2d minus 11. So therefore, this is nothing but, so a plus b, a minus b. Therefore, in the denominator 4d square minus 11 square. 11 square is 121. So again the multiple 2d into sin x, we will get 2d of sin phi x minus 11 into sin phi x. So d means d by dx differentiation. Therefore sin phi x, differentiation of sin phi x is equal to cos phi x. Again differentiation of phi x is equal to 5. So now again we can replace d square in terms of minus a square. Simplify it, we will get this term. Therefore particular integral for the first case, one is 10 cos phi x minus 11 sin phi x divided by 884. Now we need to find the particular integral 2. So 1 by 2 into 1 divided by d square minus 4d plus 3 into sin x. So 1 by 2 into 1 divided by, so in wherever d square is there, we can replace minus a square. So replace it, we will get again this. Again take the conjugate. So simplify this. So replace d square in terms of a square. We will get particular integral 2 is equal to sin x plus 2 cos x divided by 20. Now we go to replace the value particular integral 1 and 2. We'll get this. Therefore, general solution is complementary plus particular integral. So replace the complementary function and particular integral, we will get a solution. So next example number 2. Solve d square plus 1 into y is equal to sin square x. So already we know that one sin square x is nothing but 1 minus cos 2x. So we can split into two terms, 1 divided by 2 minus cos 2x by 2. So now we go to find the complementary function. Replace r of x is 0. So from this the auxiliary equation d in terms of m. Therefore m square plus 1 is equal to 0. So m square is equal to minus 1. So m is equal to plus or minus I. Here alpha is 0 and beta is 1. So complementary function is e power 0x. So a cos x plus b sin x. So complementary function is equal to a cos e power 0x is 1. Therefore CF is equal to a cos x plus b sin x. So particular integral is equal to 1 divided by d square plus 1 into 1 by 2. So 1 by 2, so 1 by 2 is nothing but we can write in the term of e power 0 x is 1. So wherever d is there, we can replace 0. Therefore particular integral is equal to 1 by 2. Now we go to find the particular integral 2. So 1 by d square plus 1 into cos 2x divided by 2. So bring the 1 by 2 outside. So cos 2x, we can instead of d square we can replace minus a square. So we'll get minus cos 2x by 6. Therefore particular integral is equal to 1 by 2 minus cos 2x divided by 6. So therefore the general solution is y is equal to complementary function plus particular integral. So replace your complementary function particular integral, you will get a solution. So next example number 3. Solve d square minus 3d plus 2 into y is equal to 2 cos of 2x plus 3 plus 2 into e power x. So now to find the complementary function, so replace r of x is 0. So the auxiliary equation is m square minus 3m plus 2 equal to 0. So therefore the roots are 2 and 1. So the complementary functions are real and unequal. Therefore CF is equal to a e power x plus b e power 2x. So now we go to find the particular integral. So particular integral is equal to 1 divided by d square minus 3d plus 2. So into your r of x. So multiple the first term and with the multiple with the second term. So particular integral 1. So we can write in terms of d square in terms of minus a square. So replace it. Again take the conjugate and you can multiply it. Simplify this, we will get a solution particular integral 1. Again particular integral 2. So now we can use the type 1. So 2, instead of d we can replace a. So therefore after replacing here the denominator is 0. 2 divided by 0. Therefore I go to multiple x in the denominator numerator. Only I go to differentiating the denominator only with respect to d. So differentiation of d square is 2d minus differentiation of 3d is 3. Therefore plus differentiation of 2 is a constant term that turns to 0. Again we can replace d in terms of a. So we will get denominator is non-zero. Therefore particular integral is equal to minus 2x into e power x. So particular integral 1 and 2. So the general solution is complementary function plus particular integral. So these are the some problems for practice for you. So after practice this, you can verify with the solution.